Hi students, in this week's video, we're going to revise some basic algebraic manipulation. The concepts are very important before we embark on the chapter on differentiation, because in differentiation, we'll be managing the product rules and the quotient rule. And in order to be able to apply these rules effectively and efficiently, it is important that we revise some basic algebraic manipulation. So do get ready a pen and a paper and practice along with me. Right, let's look at how we can actually manipulate 7 over 2x. You'll be asked to differentiate 7 over 2x. So, but before we actually apply the rules, the differentiation rules, we need to simplify this expression. Right, so how do we simplify it? Yes, basically you can break it up into two separate fractions, 7 over 2 times 1 over x. And then that will give you 7 over 2 x to the power of negative 1. Right, so once you have simplified in this, what do you call that, in this form, then we can apply the rules of differentiation. Let's look at, yes, so the chapter on differentiation is very closely related to the chapter on indices, because we'll be using some of the rules from indices to simplify the expression before we apply the rules. So what are the concepts we've learned in the chapter on indices? For example, the first one, 1 over a to the power n, we can convert it into the negative index, which is equals to a to the power of negative n. Okay, so if you have 2 over a to the power n, you can actually write it as 2a, then a to the power negative n. The negative n only belongs to a. Okay, the 2 is still 2 because it still is at the numerator. How about this? All right. Okay, if you have this, then it's the same example as what we have done earlier on. This can be simplified as half times 1 over a to the power n, and hence it becomes half times a to the power negative n. Yes, and what happens if we have to deal with radical form? This is called radical form. You would have to simplify into the index form first, and then change it to the negative index. Okay, this one can change it to the negative index, this one. This will give you a to the power of negative n over m. Right, square root a is a to the power half. And this one will give you a to the power negative half. This will give you a to the power negative 1/3. All right, so these are the rules that you have to keep in mind. Okay, it will come in very handy when you solve problems. Okay, when you need to solve the problems, differentiation problems. Okay, let's look at the next one. Right, so we can break it into two fractions, 5 over 2 times 1 over square root x. And 1 over square root x is x to the power negative half. Right, let's look at the next one. Okay, so this is where we have to apply the radical one, change it to index form first. But let's separate it first. Let's separate it into 1/3 times 1 over the 4th root of x squared. Right, and then apply the changes to the index form. And then changes into negative power. 2 over 4 is half. So that gives you x to the power negative half. Okay, right. So you need to know how to manipulate all these fractions into the forms that I've shown you on the screen. Okay. Right, let's look at another question. Supposing you're given the fractions in this form, a lot of students would just jump in and use the quotient rule. That's fine. Using quotient rule is fine. But we all know that quotient rule involve a few steps. And if you do not, if you're not careful with it, it's quite possible that you make mistakes along the way. But if you can actually simplify the expressions into individual term, then you can just differentiate the individual term without having to apply the quotient rule. So how do we do it? Yes, so we can separate it in this way, right? Okay, right. But I need to caution you folks that you can only do that when you have one term at the denominator. What I'm saying is that if you have 2x over, if your denominator has many terms, all right, this is not equal to 2x over 3x squared. Okay, this is a no-no. This is a wrong concept. Okay, see the not equal. So please take note. Okay, so you need to apply it correctly. Right. Common mistake. Right. Some students like to do it this way. Okay. Are you able to point out the mistake? Yes, the mistake is correct. Okay. You need also to change your 2 to 2 to, actually this is not 2. It's not over 2, it's half. It's 1 over 2x. So therefore, you need to convert. This is actually a fraction. This is actually half times 1 over x. So if you want to convert it to a negative index, then it should be to the power negative 1, not 2. Okay, so that is the mistake that some students may make. So if you want to do it this method, you have to be very careful. Okay, so as the results, you won't get 6, but you actually get 3 times to the power negative 1. That gives you 3 over 2, which is what we have here. Okay, likewise, it will be 2 times to the power negative 1, and to the power negative 1 is half. Okay, so that gives you 1, because x to the power of 0 is 1, and then to the power 1 times half will give you 2 over 2, 1. So 1 times 1 gives you 1. Yes, and that should be to the power of negative 1. That's half times. Okay, right. So another way is you can just pull out your half. Right, if half is the one that disturbing you, just pull out your half. Okay, and you just changed your this denominator to x to the power negative 1. And you can still get the same answer as what I've got in the first case. Okay, and you can still differentiate it individually. Right, let's look at the next one. All right, so likewise, we're just going to separate it into individual term. Okay, or we can just do it this way: 5x squared over 2 square root x plus x over 2 square root x. I think this way is easier. I would prefer this one. Then from there, that will give you 5 over 2. Right, square root x is x to the power half, so that is 2 minus half plus half x, 1 minus half, because this one means the power 1, minus 3 over 2 times x to the power negative half. Okay, and that will give you 5 over 2 x to the power of 3 over 2 plus half x to the power half minus 3 over 2 x to the power negative half, which you will get the same answer with what I've done earlier. But can you see that the steps are fewer? Okay, so I would I know some students actually learn this method, but I think it's easier just to separate them, into each term individually. Okay, let's look at the next one. The next one, basically, you will see that, yeah, some people will just apply quotient rule, which is not a good move, because this can be converted to x plus 1 to the power half, and basically you can just apply, your the one of the rules you learn in integers that will give you a to the power m minus n. Okay. All right. So I'm going to show you. Okay, just a shortcut. So that will give you just half, right? Bracket x plus 1 to the power of 2 minus half. Okay, right.